Hey guys, welcome back. In this video, we're going to talk briefly about some recursive formulas, and specifically the geometric sequence. And it's a lot like the arithmetic. If you followed that, I know it's tricky to understand. I do get it, and unfortunately, it isn't as useful as the explicit formula. All right, so what it means is a recursively defined geometric sequence says that to find a term, you have to use the previous terms. Each term is a product of the common ratio r and the previous term. Remember, n minus 1 is the term before n, or f of n minus 1, and f of n is the term before f of n plus 1. In other words, if this is f of n, that's f of n minus 1. And that would be f of n plus 1. I know it's confusing, and I'm sorry about that, but there's not much more I could do. All right, so my first example here, and I'm just going to talk through this one, then I'll do one with you. This is just say if you had this sequence right here, first you'd have to calculate r. 2 divided by 12 is 1/6 when you reduce the fraction. Pretty simple. And all we have to do to get to the next term is multiply by 1/6. In other words, the next term after this one will be 2 times 1/6, which is 1/3, and so on. So the way we would write that, and it's very simple, you're always going to have this f of n minus 1 notation right here. That says previous term. 1/6 is your common ratio. That's what it says r times f of n minus 1. Start with 72. That's what it says. Now put that note here. This also says next equals now times r. Start here. Well, we start at 72 to get this sequence. All right, I'm going to come down here and do an example. We'll do the explicit form. And this needs to be example 10, it looks like to me. A little mislabeled there. Okay, so we're going to come over here and we'll find a recursive form for this sequence. And then we'll go find an explicit form. So let's pull up this little drawing pad here and see what we can do with this thing. So our sequence is -4, 24, -144, and it goes on infinitely. All right, we notice that this is a geometric sequence. We calculate r, that's your first job. R is equal to 24 over -4, and that's -6. All right, so quick work with that. Now, you're going to find this I hope you find this very easy. To write the recursive form, we'll write that here, recursive. We would say f of n is defined as next. Take the term before it and multiply by -6. You might like it better with that out front. You need it to be negative. And I think that's the way I wrote it in the notation. Then we got to say start with f of 1 is -4. And that's your recursive form. And usually I wish I had put that in one line, but what it says is -6 times the previous term gets you to the next one. Let's see if that works. -6 times -4, 24. 24 times -6, -144, and so on. Again, not very useful. Somebody says, what's the 50th term? I'm sorry, you're going to have to find them iteratively, and that's going to take a lot of time. Or you just write the explicit form for the same sequence. And this is just an example of what the explicit form would be. We already know that r was -6. So we would write f of n is the first term minus 6 times n minus 1. Now this is explicit, right? And always, I like to simplify these. Okay, so we're going to distribute -6 to n, -6 to -1. So you get -6n plus 6. And our final simplified version, we got to put this thing out front. I like it to be in order. 6 minus 4 is 2. And this will give you your sequence. Put in n as 1, you get -4, and so on. This is the more valuable formula. This guy can predict terms anywhere you have them. You want the 50th term? -300 plus 2, so -298. This one works really quick and good. All right, I'll fill in the notes before you get there to look at it. Last example here is I want to take a look at, given a sequence like this, find the first 4 terms of the sequence, and we need to write this thing down. Let's see. I've got 1/2 f of n minus 1. F of 1 is 64. All right. So let's take this and find the first 4 terms, because that's a question that could be asked of us. If we have f of n is equal to 1/2 f of n minus 1, start with 64. And then I'm told to find the first 4 terms. Well, the first term is 64. We know that, so that part's done. Now this notation says, hey, multiply him by 1/2, you'll get to the next one. That's 32. Multiply him by 1/2, you'll get to the next one, 16. Multiply him by 1/2, you'll get to the next one, 8. And there's your first 4 terms. It's that simple. So the notation says multiply the previous term by 1/2, and you'll get to the next term. Okay? Now, another question, and I hadn't planned to do this, they could ask us with this. Suppose they ask the question, find the 10th term instead of saying find the first 4. You could iteratively find your way to 10 using brute force, or you could write a formula for the nth term explicitly, which would be 64 times 1/2 to the n minus 1, and plug in 10 right there. So in other words, you'd be finding f of 10. And, time minus 1, which is 9. Anyway, you could put that in your calculator and compute it. That wasn't the question, however. I know I went off on a tangent there. We're asked to find the first 4 terms, but they can also give you a recursive form and ask you for the 10th term or something like that. And you don't have to do it iteratively. Just find the first couple of terms. Well, actually, you know R. In fact, you wouldn't even have to do that. You know what R is, and you know what f of 1 is. You could use this right away. It's just showing you know something, okay? Well, I hope you found this helpful, and I'll see you in the next video.